Hello, this is Pat Kelly. Okay, in this problem, they give us a differential equation. They ask us to verify that it's exact, but then also to find the general solution to it. Okay, so let's get started. And if we're going to check to see if this is an exact differential equation, which they told us it is, but to verify that, and actually even in the work that we need to do to find the general solution, in either case, you want to start by getting some labels on what we call M, capital M, and we're also going to need a capital N. Let me switch colors for you. But when we do this, your capital M is just everything that's being multiplied by the dx, and your capital N then is everything that's being multiplied by the dy. Okay? All right, with our handles on those, the test that we do to see that it's exact, or in this problem to verify that it's exact, is we need to look at the partial derivative of m, but with respect to y, and see if that equals the partial derivative of n with respect to x. Okay, this is actually a question mark. We got a C, and we get our m from up there. We get our n also from up there. So the work I'm going to do right now is go ahead and do the partial derivative of what's underlined here in orange, but with respect to y. So the derivative of this first term is going to be 6y. Second term with respect to y looks like it's going to be a 20. X is a constant when we differentiate with respect to y, and y goes down a power. That's my left-hand side of this check. We want to see if that equals still a question mark for me. Question mark. See if that equals, now let's differentiate this n expression, but with respect to x. So my y will be a constant. This looks like just 6y then. Minus 2, differentiate that, that's going to go to 0. Differentiate this third term with respect to x. Looks like a plus 20. X drops down a power, and the y is a constant like a coefficient, so it's still there. Take a look, left-hand side, right-hand side are the same. Okay, we've confirmed that it's an exact differential equation. Now, maybe more importantly, let's find the answer. Let's find the general solution. So let me slide over here. So the main work you're going to do to find that general solution is you need to find lowercase f of x, y. Actually, how you label it's not important, but that's the standard. So the big chunk, the biggest component of your answer for the general solution is this function of x, y. And then you'll see once we get it, you also you put that on the left-hand side of the equation and then throw a constant on the right-hand side. You'll see, we'll do that together. But first focus on getting this little f of x, y. How you do that is you're going to do some integration, and you actually have your choice. You can integrate that m expression with respect to x, or you can integrate this n expression with respect to y. It's almost a toss-up. It'll be about the same amount of work in either case, but I think I'm going to go to the m expression and integrate that, really only even because that has 2 terms and my capital N has 3 terms. Maybe it'll be easier to integrate. So I'm going to integrate the capital M with respect to x. Okay, what color was that? Orange. So I'm going to grab my m from what we labeled at the beginning. I'm just going to go ahead and integrate this. Integral of my m expression was 3y squared. And then plus 10xy squared. Okay, and I'm integrating all of that with respect to x. Okay, slip here, and if I'm integrating this with respect to x, that's just going to be 3xy squared. The x bumps up a power to 2, and then divide by that 2, so that coefficient will be 5, right? X is going up to the 2 power. The y is still there. And then it's important you remember this next thing. Usually when we integrate, we tack on a plus c if it's an indefinite integral. We're actually doing that, but because these expressions could involve either x or y, it's possible that what we tack on could have had some y's in it, and then it would have just differentiated to 0 with respect to x. And so maybe that's why we're not seeing it here in the orange. What it really comes down to, if you remember, is your tack on here is possibly a function of y. Don't say plus a constant. Say plus something that might involve y in it, so g of y. Okay? All right, that's good. This is a pretty good start to what f of xy will look like, but we definitely want to get a handle on what that g of y looks like. So what I do next, I think I'll slip over here for some room. But I'm using this f of xy, and I actually do the partial derivative of it with respect to y. So I'll put a subscript of y there, of the x, y variables. And so what you want to keep an eye on is I'm going to differentiate this with respect to y. So the derivative of that first term looks like 6x y to the 1 power. Second term, the 2 would come in front, plus 10x squared, and y drops down a power. And the third term, this is important, you are differentiating that third term with respect to y. We don't know what it is exactly, but I can express the derivative of g of y with respect to y as g prime of y. Okay? So this is my derivative of f of xy with respect to y, partial derivative. What's the significance of that? Well, I'll switch colors again, go to green. This is the significance, very important significance. This must equal n. And n was our expression up here to begin with. Okay, so that must equal my 6xy minus 2 plus 10x squared y. Okay, we're in good shape. Because if these two things must equal each other, look at how they compare right now. 6xy is there on both sides, on each side. The 10x squared y is there on each side. So in order to get the balance, this g prime of y must equal -2. So slip over here. So g prime of y must equal the -2. Okay, and that's good, because now if I just step down one line, we can figure out what g of y is by anti-differentiating, integrating. So if I integrate this, you get -2y. Technically plus c, but you see, we never really worry about that too much as long as we account for it at some point, like at the end of the problem, which is where we're at. Okay, so let's get our final answer to this. Our final answer is primarily that f of xy, when I was kind of rambling about that before. You want to grab this expression, 3xy squared plus 5x squared y squared plus g of y, which we now know is minus the 2y. That exponent there is 2 if it's big enough. Okay, and then my rambling was that that's primarily your answer. That's the largest chunk of it. But then you also have a right side of an equation here. All of that's the left-hand side. And the right-hand side is just some constant. And you just put our C, capital C for constant. Okay? And just for exactness here, these aren't necessarily the same C's. So that's why you see a lot of the subscripts there, like C sub 1. But this is my general solution. General solution right there, okay? You pat yourself on the back. We did a good job on this one, but make sure you practice some on your own too, okay?